Okay, today I'm going to go over these additional problem solutions for topic 7. The first question is, these are inequalities, and the first one is 2x plus 2 is less than 8. Okay, so remember we can add and or subtract anything from either. If we do it to one side, we have to do it to the other. And our goal here, since the power on the exponent is 1, since the power on the exponent is 1, the highest power, our strategy is just like we do for equations that are linear and have that highest power of 1, is to get x by itself. So we're going to subtract 2 from both sides. And then, just a little bit, and then bring down that inequality in the same way it was written, because we didn't multiply or divide by a negative. So we keep that inequality the same, except for that one case, which this is not it. 8 minus 2 is 6. Okay, now we're going to divide both sides by 2. 2 is a positive number. So since we're dividing by 2, this inequality does not change. It stays less than. So 2 divided by 2, right, is 1. So this is just x. And 6 divided by 2 is 3. So we have our algebraic answer, but if we're going to write this in interval notation, you could convert this from the power line, from a number line. So if we were to graph at 3, because x is strictly less than 3, okay, that means it does not include 3. We would put an open circle at 3, and we would go to the left. So everything less than 3 is what this means. And the way we write this in interval notation is we now, off the number line, read this left to right. So starting at the most negative it's going to go is negative infinity, but it can't get there. So we have a rounded bracket all the way up to 3, but you can't quite get to 3. So we have a rounded bracket there. And this is our final answer. Okay, the second additional problem is negative 12 less than or equal to negative 3x. And this is a really very simple problem. It is just really getting you to make sure you understand one thing, and that is that if you divide by a negative, you have to flip the inequality. So the key thing that we're looking at in this problem is that in order to get x by itself, we have to divide by negative 3 on both sides. Because of this division by negative 3, we have to flip this inequality. So on the left side, the right side, negative 3 divided by negative 3 is just 1, right? So that's just a hidden form of 1. So these cancel out. And then we're just left with x. And on the left side, we have negative 12 divided by negative 3. And negative divided by a negative is 2 negatives, and that's a positive. So, and 12 divided by 3 is 4. So this is 4. Now, whenever you end up in a situation like this, even though this is algebraically done, it often is easier to read it if you put the x on the left. So if we're going to rewrite this, so rewriting this, we would say x, and we notice that the pointy side of this is pointing to the x. So we make sure that the pointy side is pointing to the x. X is less than or equal to 4. So for this, we'll do a number line. At 4, we have a solid dot because of the equal, this line underneath, right? Less than or equal to means this is a solid dot, and we're going to do everything to the left where x is less than. So in interval notation, this is from negative infinity, which we can never get to. Okay, so this little arrow is just saying that's where that's coming from, comma, the whole range all the way up to 4 square bracket. And the square bracket is coming because it's less than or equal to, it includes the 4. And we signify that in interval notation with a square bracket. So this is our answer to this problem. The next problem, number 3, is the first one where we do 2 problems in one. So I'm actually going to erase all of this, so we have enough room. For number 3, we have 0 is less than or equal to x plus 1, and that's less than or equal to 4. As I told you in class today, this is really 2 problems in one. So what we're going to do is solve both of them. It's 0 less than or equal to x plus 1 and x plus 1 is less than or equal to 4. But we can answer all of them all together because whatever we do to any one of these 3 spots, we have this spot, the middle spot, and the right spot. Whatever we do to one, we got to do to all of them. So the first thing we're going to do is try to get x by itself. So this, we're just going to subtract 1 from each side. And we go ahead and we add this down and we end up with -1 is less than or equal to x is less than or equal to 4. So at this point, this one is done. And we can just put this on our number line. And these are going to be the bookends because x is in the middle. It's between -1 and 4. It's greater than or equal to -1 and it's less than or equal to 4. So we can go over here to -1 and we can go to 4. And if you want to throw in a 0 for reference, you can. And the answer is x greater than or equal to, so it's a solid line of -1, all the way up to 4, which is less than or equal to. And again, because of the line underneath the inequality sign, we know we have equal. And we have this range of numbers in between. To write that as an interval, we're going to go from -1, and we're going to use a square bracket because it's including -1, comma, the whole range over to 4. And again, because 4 is included, it's a square bracket. So it's this -1 to 4, and this is our answer. Okay. The next problem, number 4, says 2 times x minus 4 minus 7 is less than or equal to 24 minus 5 times 2x plus 3. Okay, so looks kind of complicated, but it doesn't have to be. We're just going to break it down and do each step one at a time. So what we're going to do is, first of all, we're going to distribute the 2 by multiplying it through these parentheses. And we're going to distribute this 5. And remember, we're going to super glue the negative to the 5. Okay? And then we're going to group like terms. So let's just take this one step at a time. The first thing is going to be 2x minus 8 minus 7 less than or equal to 24. And it's going to be -5 times 2, so minus 10x, and -5 times 3, or minus 15. Okay. Now we group like terms. So on the left side, we have 2x minus 15 is less than or equal to, we have 24 minus 15. Okay, so that is 9. And then minus 10x. Sorry, I was thinking I was doing that wrong. But yeah, 14 minus 5 is 9, yes. Okay, now, if we add, now we're going to bring the x's all on one side. So one way we can do this is we notice that there's an x here, and we're going to pull it over to the left. We're going to take this -15, and we're going to pull it over to the right. So the way we're going to do that, the way we can't just do that, right? We have to add and subtract stuff. That's sort of like a way of thinking about it, but really we're going to add 15 over to both sides. And we're going to add 10x to both sides. And then we're going to do the math. Because we just added, it doesn't matter if we added or subtracted, the inequality stays the same. So it's less than or equal to. We have 12x. negative 15 plus 15 goes away. And here we have minus 10x plus 10x. And so we have 0. And then instead we have 9 plus 15. And 9 plus 15 is going to be 24. So when we divide by 12 on both sides, we're dividing by a positive number. So we don't have to in any way change the inequality. This inequality stays the same. And on the left, we have x less than or equal to 2. Okay, the next problem is our first word problem. This one says that the relationship between Celsius and Fahrenheit temperatures is given by the formula. So let me write this down. Is given by the formula C equals 5 nines times Fahrenheit minus 32. And then the first question, A, says, if the temperature range for Montreal during the month of January is given by negative 15, less than whatever that it was, the measure of temperature in Celsius, less than negative 5, and I think there's a little degree here, minus 5 degrees. Then what is the range if you were to convert this to Fahrenheit in Montreal for the same month? Well, what we're going to do is we're going to take advantage of this formula and we're going to stick it right in the middle, because if we know that this is true for Celsius, and this is what Celsius is, and this is equal. So because this is equal, we can now make a substitution. So we're going to go from negative 15 less than, and now instead of C, we're going to write 5 nines F minus 32 less than negative 5. Okay, and now we're going to go ahead and solve this for F so we can find the range for F. So the first thing we're going to do is we're going to get rid of the 9. So we're going to multiply everything by 9. And the reason, oh, by the way, when you look at this, make sure you see it, that this is one block of stuff multiplied by a whole nother block of stuff. So the first thing we want to do when what we're looking for is buried inside one of these parentheses, is we're going to get rid of whatever is multiplied by it in front of the parentheses, and then we'll deal with what's inside the parentheses. So the first thing we want to get rid of is this 5 ninths. So I can do it in 2 steps. I might as well. I can multiply this by 9/5. So I'm going to multiply every single thing by 9/5, or the reciprocal of this. So I'm multiplying this by the reciprocal. And I have to do it over here on the right too. Okay. Well, the 9s are going to cancel and the 5s cancel. That was the whole reason I picked 9/5, right? So on the left, we have that 5 goes into negative 15 3 times, and 9 times negative 3 is negative 27. And that's less than, now in the middle, we have F minus 32. And over here we have negative 5 times 9/5. The 5s cancel, leaving this as a negative 1. Don't forget that negative right there. So this is negative 1 times 9, or negative 9. Okay? Now, we multiplied by a positive number, so those inequalities did not flip. Oops. I pointed to the wrong spot. Hold on. Here we go. So now we want to get F by itself. So now we're going to add 32 to both sides, to all 3 sides, all 3 locations. So we're going to add 32 over here, and we're going to add 32 over here. Because if I want to keep the inequality to be true and accurate, what I do to any one part of the inequality, I need to do to the other parts. So here I have 32 minus 27, or 5 degrees, less than F in Fahrenheit, which is less than 32 minus 9, So that's 23 degrees. So in the month of January in Montreal, in Fahrenheit, which is more what we're used to thinking about, the temperature goes from 5 degrees to 23 degrees. That's the average. Okay, now let's look at part B of this problem. So I'm going to erase part A so I have room. So for part B, we're told that the temperature range in New York City during the month of June is 63 degrees and between 63 degrees measured in Fahrenheit up to 80 degrees. So this is a little tricky because we can't substitute this formula in directly now. So what we first have to do is we have to remember what we learned back in section, I think I'm losing track of where we learned it, but it was where we solve, oh, I think it's section 5, where we take an equation and we solve for a given variable. So this is solved right now for C because it says C equals this whole formula on the right. But now we're going to turn this around and we're going to instead solve for F. So let's do part B has this pre-step. So we're going to call this the pre-step because we need a formula for F. We have a pre-step. We have to solve for F. So we have C equals 5/9 F minus 32. All right, so just like we did before, but now we're going to just do it without being able to get a number, but the steps are the same. Put this equal sign a little closer to the C. I'm going to multiply by the reciprocal. I know F is in here. I want to end up with F equals something. So I want to get rid of what's in front that's multiplied. So I'm going to multiply by the reciprocal. So I'm multiplying by 9/5. And if I do it on one side of the equal sign, I have to do it on the other side of the equal sign. Okay. Now this, the 5's cancel and the 9's cancel. This is all 1. So I have that 9/5 C is equal to F minus 32. And now to solve for 32, I just have to add, now to solve for F for the Fahrenheit, I got to add 32 to both sides. Okay, so on the left side, there's no like terms here because this is 9/5 is the coefficient of the C, 9/5 times C plus 32. So that I just have to write out, 9/5 times C plus 32. And that's what F is equal to. So now back up in here, I can go ahead and plug that in. I'm going to need a little space, so I'm going to erase this right here and come up to the top. I'm going to rewrite now this formula with this formula for F. I'm going to substitute what F is in terms of Celsius into this formula. So I have 63 is less than 9/5 C plus 32, and that's less than 80. So now we have to try to get C by itself in the middle, and we see that we have something added on. In the previous problem, something was multiplied, but here we have something added on, so we're going to subtract 32. And if we're going to do it in the middle, we got to do it on each end as well. So we're going to subtract 32 from all sides. Okay, and now we're just going to carry out what that math is. So 63 minus 32 is going to be 31. Okay, we'll just subtract that. And that's less than 9/5 C plus 32 minus 32. This goes away, right? And we're just left with 9/5 C. And that's less than 80 minus 32. Well, let's see, 10 minus 8 is 2. 7 minus 3 is 4. Okay. So now we have 31 is less than 9/5, which is less than 48. Now that we have no things added or subtracted to where our variable is, all we're left with So first you get rid of things that are added or subtracted. And you get down to where the variable is and you get rid of anything that's multiplied by where the variable is. So once again, we're going to multiply this by 5 ninths. 5 ninths. I'll go ahead and put parentheses to emphasize that we're multiplying. Okay, these go away and that just becomes 1. So we have C is less than these two numbers. And I need to get my calculator out to do that math. So let's see what that works out to be. We have 5 times 31 divided by 9. And I get 17.2222 non-repeating. So I'm going to say this is 17.2, just rounding to 1 decimal, degrees, Celsius degrees. And 48 times 5 divided by 9. And here I get 26.7 degrees. Okay, so if you had to write this in using words, convert this back to words, you'd say in New York, in the month of June, the average range in Celsius of the temperature is 17.2 degrees to 26.7 degrees. Okay. Now let's go on to problem number 6. Here we're told that a particular Dunkin' requires that Maria spend $4 or more if she wants to pay using a credit card. Now catch that word, $4 or more. So let's just write this out. Maria, to use a credit card, so I'm going to abbreviate this word problem a little, needs to spend $4 or more. So whenever you see something that is $4 or more, another way to translate that in your head is at least $4. Okay, so one or the other may help. So it's $4 or more, it means that's the least she can spend is $4. So it's at least $4. Okay, and we see that a coffee costs $2.20, and that donuts cost 90 cents each. Okay. And we're told that Maria wants to use her credit card, and she wants to get a coffee and some donuts. So what's the least number of donuts that Maria has to get that will enable her to use her credit card? Okay. So if Maria is going to spend money, how much is that money going to cost? So Maria's spend is going to be $2.20, right? So now let's think about what we don't know, the number of donuts, right? We're being asked, what is the number of donuts that Maria has to buy? So let's go ahead and give that variable a symbol. I'm going to give it D, and let's define it. And sometimes for definition, we use an equal sign with 3 lines. Let's say this is the number of donuts Maria buys. So the amount that Maria spends is going to be the $2.20 plus 90 cents times the number of donuts she gets, right? And what we need is that this amount be at least $4. That means it has to be greater than or equal to 4. So now we've taken our word problem and converted it into an inequality. And this is very common. This is why we're doing word problems in the inequality topic, because we often have a situation where we have a word problem that really isn't about finding an exact value. It's about finding a minimum or a maximum. So here, the minimum that Maria has to spend is $4, and we need to figure out how many donuts she has to buy. She can always buy more, right? So, okay, so first thing we're going to do is we're going to subtract the 220 from both sides, because we see that the D, which is what we're trying to solve for, has this stuff added on. So we get rid of anything that's added or subtracted to where the term is with our variable. So we're going to subtract that 220 from both sides. This is going to go away, and we're left with 0.9D on the left is greater than or equal to 4 minus 220. So if you put that in your calculator, we get 4 minus 220 is $1.80. Okay, and then you see we don't have D by itself, so we have to divide by 0.9. So we can divide both sides by 0.9. Now 0.9 divided by 0.9, anything divided by itself, it doesn't matter if it's a fraction or not, is 1. So, and 0.9 is positive, right? 0.9 is greater than 0, positive. So we don't have to change the inequality. It's going to stay greater than or equal to, leaving D on the left. And 1.8 divided by 0.9 is 2. So Maria has to get at least 2 donuts to use her, I'm going to say CC because I'm kind of getting low on this board, credit card. Okay? So that's how you solve that one. Now let's go on to number 7. Number 7 says, Sam and Tom are working on similar jobs, but their annual salaries differ by more than $6,000. That's a bummer. If the annual salary of Sam is more than Tom, and Tom earns $27,000 per year, then what are the possible values for the annual salary of Sam? Okay, so first of all, let's go ahead and, so that's step 1 is we want to read the whole problem, okay? And then we kind of want to understand what is it that we're looking for. And we're trying to find the values for the annual salary of Sam. So annual salary of Sam. And let's define that with just S. Okay, so that'll be what we're kind of trying to find out about. So we give the thing we're looking for a variable. Now, that's step 1. Well, that's actually technically step 2. But then step 3 is you kind of go through it again and you start writing down what you do know. What are the relationships? You try to convert the words to math. So now we know we want to find something about the annual salary of Sam. We want to know what is it at least? We know it's more than Tom's. We want to know by like what could it be more, right? So what we're told is that Tom's salary is $27,000 per year. And so, and that Tom's salary, which is $27,000, minus Sam's, okay, the difference between them, or I should do it more, actually, let's do it the other way around. Sorry, I just realized they do tell us that Sam is more than Tom. So Sam's minus $27,000 is they differ by more than 6,000. So that you take what Sam makes and you subtract what Tom makes. So this is Tom's salary. That's greater than 6,000. Okay? So then what we want to know is, what is possibly Sam's salary? What is the minimum that it could be? So now that we've set this up, we go ahead and we solve this by just adding 27,000 to both sides. We didn't multiply or divide by anything, so the inequality is definitely not changing. This cancels out, and now we have S. Sam's salary is greater than 6,000 plus 27,000, or 33,000. So we don't know exactly what Sam's salary is, but we know it's greater than Tom's by at least 6,000. Sam's salary is at least $33,000 per year. Okay, all right, let's do one more. Okay, number 8 says a worker can choose to be paid by either Plan A, which is $500 plus $70 per hour. This is a weekly. Or Plan B, which is $120 per hour. If the worker works X hours in a week, for what value of X, like let's X represents how many hours per week the worker works. So how many hours makes Plan A better than Plan B? You know, what's the cutoff? Like, let's say you're going to be working and you have this option and you can choose how you want to be paid. And you want to know, like, let's say you definitely know how many hours you're going to work. Then you want to know which of these two plans is better for you. So let's figure out at what point one plan switches over to being better than the other one. So let's first of all write them out. So we got Plan A. So Plan A says that you get 500 plus $70 per hour. So 70 times X. So let's remember, X is number of hours worked. So with Plan A, you would get $500 plus 70 times the number of hours worked. And Plan B is straight up $120 per hour. So that's 120 times X. However many hours you work, you get 120 for each one of those hours. I'd say that's a pretty good salary. All right. So we want to know, when is Plan A, what is the X value for when Plan A is the better plan? And what do we mean by better? When is Plan A better? And by that we mean pays more, in case that wasn't obvious, than Plan B. So really what we're saying is, when is 500 plus 70X better than Plan B? Right? So I just took what I wrote out. I wrote out the question, and then I start substituting in the information that I'm given so I can turn the word problem into a math problem. Okay. Now notice, when it's a math problem, we have X on both sides. And over here we have an extra 500. So I'm going to subtract the 70X so I can group like terms on the right. So I'm going to just subtract the 70X here from both sides. And because I'm just adding or subtracting, the inequality is not going to change. So it's just going to be greater than. So on the left, I get 500 is greater than 120 minus 70X. So that's 50X. All right. So now I want to get x by itself, so I'm going to divide by 50 on both sides. Okay. And these 50 on the right cancel out to 1. So this is x. And 500 divided by 50 is 10. So again, we ended up with x on the right. It's a little hard to translate into English. Think about it with x on the right. So rewrite this with x on the left. So we're going to rewrite this as saying x with the pointy side pointing into it less than 10. So the answer is plan A pays more if the worker works no more than, or another way of saying that is less than 10 hours for that week. Okay, if not, if they're going to work more than 10 hours, they better go with plan B because that'll end up paying them better. Okay, that's it for today. Any questions, come and see me.